All right, folks, welcome back to Mike and Maurice's Mind Escape. We have episode number 207 today. We are joined again by Avi Loeb. He has a new initiative. It's called the Galileo Project, which we are going to be talking about today. He is also the Frank Baird Professor of Science and Harvard Astronomy Department Director. He's also part of the Black Hole Initiative, Harvard Faculty of Arts and Science. List goes on. The guy's very well accredited, and we're happy to have him back on. And also, he's an author. We just had him on last time when we discussed Extraterrestrial, which is his book regarding Oumumua and possible remnants of extraterrestrial civilizations and life out there. Before we get started, head on over to our Patreon at patreon.com/mindescapepodcast. For just $2 a month, you'll get exclusive guest episodes and segments. We do have actually a Patreon from the last time we had Avi on, so if you're interested, go check that out. We talk about UAP and UFOs. And one more thing, head on over to indrasweb.org. This is the social media platform we created to connect open minds, whether it's this topic or other similar topics. It's a perfect place to theorize, speculate, hypothesize, all that great stuff. So, but without further ado, welcome back on the show, Avi.
Thanks for having me.
Thanks for joining us.
Yeah, this is awesome. And I was just mentioning off air, you're a man of your word, because last time you were on, we were discussing all the UAP stuff and all the videos and David Fravor's account and all the different stuff that was happening with the military. And you said, well, why don't we take a closer look? And that's exactly kind of what you're doing now with this Galileo project. So why don't you give us just a basic summary of what you will be doing with the Galileo project?
Right. So I should say, actually, I kept my word on two other aspects. I was saying that the study of objects that look weird, that might belong to an extraterrestrial civilization that sent them, that study by itself is of great interest to the public. And I was arguing that it should be mainstream in science because it's a way of getting more funds to science if we address it scientifically, and moreover, attracting young talent to science. And it was an abstract argument a few months ago, but I can say that with great satisfaction that over the past week, I demonstrated that because I received donations totaling close to $2 million over 2 weeks without fundraising whatsoever from people that read my book, Extraterrestrial, that approached me and said, here is the money, no strings attached, and use it for that purpose. And the second thing that happened was once we announced the Galileo Project, I had thousands of emails over the past few days from people that are so excited about the initiative. They want to help, contribute from their time, and also contribute financially. So I rest my case. Okay, the subject definitely is a win-win proposition for science. And moreover, for humanity, we want to know whether we are alone. Is there a smarter kid on the block? And of course, we can argue that we are the smartest and nobody is out there by closing off our windows and never looking through our windows. But that would not get rid of our neighbors. You see, if we have a smarter kid on the block, that smarter kid is there, right, irrespective of whether we look through the window or not. So my point is simple. Let's just collect evidence. And it's a fishing expedition. You don't know what you will find, what kind of fish you will catch. And so I was arguing that. And then, of course, the Pentagon report came out a month ago. And then the head of NASA, Bill Nelson, was making the case that scientists should look into this subject because it's intriguing. And the government admits that there seem to be real objects out there in the sky that whose nature is not understood. Okay, and by the way, it's an admission in the failure of the intelligence community, because that's their job. They're getting paid to figure out what flies in our sky. That could belong to an adversary, to another nation.
That's actually an interesting point. I wanted to ask you a question about that. So I want to get into like the instrumentation and what you're actually going to be doing with the sensor stuff, but Before we get into that, if you find something with this project, do you have a duty to relay that information to the government, or is this something you can just make public without that intermediary? Or
well, I will get to that. What we will do is collect open data, not data that relies on government-owned sensors, which is often classified. The reason we just see the tip of the iceberg in terms of the data the government owns, because it was collected by sensors that are classified.
Right.
We don't want to let our adversaries know what we use in order to monitor our sky. And that's the reason why a lot of the data is classified. But if there is a scientific experiment, just like in astronomy, in astronomy we have observatories looking at the sky. The sky is not classified, and the data is collected and then published. And it's open, and anyone can analyze it. That's the way science is done. And that's the way we plan to conduct this research project. So what happened was, Bill Nelson, the head of NASA, said, yes, it's something that the scientists should look into. So I approached people under him, and they didn't get back to me. And then fortunately, a week later, some wealthy individuals approached me, people that I didn't know, and they provided funds, at which point I said, now I can do it. Let's just do it. Why do I need to rely on other people helping me if I have the money myself? I assembled a team of exceptional scientists, mostly astronomers. And what we are planning to do is construct telescope systems. And by that, I mean, we buy components that are off the shelf of telescopes and then connected to cameras that are suitable. And the data stream that will come from the cameras will be going to computer systems that will analyze it and filter out objects of interest, and then instruct the telescope to track objects of interest. So in a way, we are using telescopes, but very differently from astronomers. Astronomers look at very distant objects, okay? And if a bird flies above their telescope, they ignore it. If a bird flies above our telescopes, we will look at it. We will monitor it to make sure that it's a bird, okay?
Yeah, or not a seagull.
So you can't say that, like some people say, what's new? Astronomers are using telescopes all the time. People are using iPhones. Well, first of all, iPhones are not suitable for this purpose.
Well, they degrade when you zoom in, like, heavily, too. The picture degrades, like, when you zoom in on an iPhone picture.
Yeah.
No. The problem with iPhones is simply that the aperture is just few millimeters. If you look at your iPhone, the camera has an aperture of a few millimeters. The resolution, the angular resolution that you get, scales inversely with the size of your aperture. So if instead of a few millimeters, you have a telescope that has a diameter of a meter, that's 1,000 times bigger than a millimeter. So your resolution is 1,000 times bigger. So what would appear as a megapixel image, 1,000,000 pixels, in a 1 meter diameter telescope would appear as a 1 pixel image in your iPhone.
Oh, okay. Yeah, that makes a lot of sense.
So it looks like a fuzzy dot on your iPhone. Whatever looks like a fuzzy dot would look like a megapixel image with that kind of telescope that 1 meter in size. So the point is, optics is really essential here. We can't use images that citizens collect randomly in their backyard. That's not scientific. And we can't use images collected by a camera installed in the cockpit of a fighter jet, because the fighter jet is jittery. We don't know the trajectory of the fighter jet. We don't want to rely on eyewitness testimonies, because humans have hallucinations. Humans, despite their best,
cognitive issues, cognitive bias, confirmation bias. We have all sorts of biases. Our memory's flawed, all that stuff.
Right, a lot of psychological issues. You can't write a scientific paper based on eyewitness testimonies, even though in the courtroom, if there is corroborating evidence by several eyewitnesses, you can put a person in jail. That's acceptable in the legal system, but it's not acceptable in science. In science, you can't write a paper saying, this fellow told me that and another fellow confirmed it. That's not scientific evidence. What you need is to collect quantitative data with instruments, okay? And that's the only thing that is acceptable by science. And so what we want is to use much better instruments than were used on Navy ships or on fighter jets. We don't want to rely on eyewitness testimonies. We want to have full control over the instruments we use. So 2 reasons for why not using government-owned sensors or not relying on military personnel. One is that we don't want to look at classified information so that it will not limit our freedom. We want to speak freely about what we see. We don't want to be engaged in some, compromised position by the government. Second, the instruments that were used in some of these reports are not optimal. We want to do the best in terms of, we want to have full control over the instruments and use the best instrument. So the goal is to have a scientific expedition, basically have a lot of such telescope systems distributed. And, the number of them depends on how much funding we have. Currently, with $2 million, we can have 10 or maybe several tens of such telescope systems suitable. But that will not give us a comprehensive study of the sky. What we need is a factor of 10 more. So if we had $10 million or more, that would allow us to have a comprehensive study of this problem. And we hope to get more funding. But with the 2 million, we can already demonstrate that it works and that we can get valuable data. And that's what we plan to do. So we have, a team, a research team. Altogether, there are about 50 people already within the Galileo Project. But the core team, which is the research team, has roughly a dozen people. And we are now working on defining the characteristics of the instruments that we want to use, and then we will purchase them. I have the money. We can go ahead and do it. So we are hitting the ground running. It's not as if, we have to wait for anyone.
Yeah, and I have the link down below if anybody's interested and wants to check out the page, the website, and look at the team and, the goal and the mission and all that stuff. I think when we were discussing last time, there's some people that have this idea that these things, if they are from somewhere else, could be manipulating gravity. Is there any tool you could use that you know of to figure out, to sensory stuff that you could use to see if there is something that's manipulating or using gravity in some weird way?
Well, first I should mention that the people that make these statements are not scientists.
No, of course.
Okay. So in the context of physics, I'm speaking as a scientist. In the context of the standard model of physics, if you have a slight, minute, tiny deviation from the laws of physics as we know them, and by minute, tiny, what I mean is if the magnetic moment of a particle that has no relevance to anything that we encounter in our daily life, called the muon, if the magnetic moment of the muon deviates by a tiny bit from a calculation done by computers that is uncertain by itself, and that deviation is not even verified as of yet, that made huge headlines, which could earn the Nobel Prize for the people studying it. Just to give you an example.
Right.
So there are plenty of experiments checking the laws of physics as we know them. We are looking at the sky and many distant sources of light, trying to see if the laws hold there. And any tiny little insignificant deviation from what we know would have earned the person that discovers it a Nobel Prize. So saying there are objects in our atmosphere that are manipulating space-time in some weird fashion, and that is the explanation for something that I've seen, just doesn't hold water, because the laws of physics are being tested routinely in numerous contexts, including technology, including experiments in laboratories, including the universe at large. And if there was a tiny deviation from what we know, it would have a huge impact on our understanding of the universe. So my point is, let's go more slowly. Okay, first of all, collect data about these objects. If they appear to be extraterrestrial, that would by itself be a huge revelation. Mm-hmm. But if on top of that you say, oh, there is an aspect of these objects that behaves differently than what we expect based on what we know about physics, that would be huge, because it will affect the way we think about the universe. And what I'm saying is, you can't go to the second step lightly. I mean, of course, people that are not scientists can do anything.
Yeah.
They can talk, they can even say that they are Napoleon. They say, I'm Napoleon. Now, if you ask them for their ID, it may say something else.
Not Napoleon.
But anyone can say anything.
Yeah.
My point is, anyone can say anything. If they're not scientists, they're not familiar with how many different experiments are being done all the time, continuously. And if there was any hint that the laws of physics are incomplete, that like we know something, first it's a Nobel Prize, second you would think immediately about practical applications for technology. So, you can't just say manipulating space-time, wormholes, all kinds of buzzwords that have no substantiation. It's just like saying I'm Napoleon. That's the comparison I'm giving you.
Yeah, no, I was just curious because I've never talked to an actual scientist about that, but yeah, that is something that gets thrown a lot around out there. And you mentioned the muon experiment from the Large Hadron Collider, or no, not large, the other one. What's the one in Chicago? Yeah, the Fermi Lab from earlier this year. So when you look at this project and everything, you know, it's not just the UAP stuff. It's also looking for stuff similar to Oumumua and near Earth objects or stuff coming from different parts of the galaxy or interstellar stuff. What are you going to do for that? Are those telescope-based experiments too, or are you going to put satellites out there, or what's going on with that?
It's very simple. So in the context of Oumumua, I should say, a few weeks ago, there was a paper published in Nature Astronomy by a philosopher arguing why, based on philosophical arguments, Oumumua could not have been technological or artificial in origin. And I said to myself, haven't we learned something since the days of Galileo? Because Galileo Galilei said, based on what I see through my telescope, it looks like the Earth may be moving around the sun. And at the time, philosophers said, no, we know the answer. The sun moves around the Earth. The Earth is at the center of the universe. They refused to look through his telescope. They put him in house arrest. And the Earth continued to move around the sun. So my point is, all that did was maintain our ignorance. We should have learned a lesson, not to rely on arguments, but rather get data. And in the context of Oumuamua-like objects, all we need is a close-up photograph of the object or an object similar to it. What we need is to find an object on its approach to us that belongs to the same family of objects, that looks weird, doesn't look like a comet or an asteroid, and then send a spacecraft equipped with a camera that will take a close-up photograph. Because they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book. I would not need to write the book. I would just show the photograph. And once you have a high-resolution image, you are done. And that's actually the purpose also of the Galileo Project, to, if there is an object identified as a UAP, as an unidentified aerial phenomena, then what we want to do is get a megapixel image of it and read off the label. Does it say made in country X here on Earth, or made on planet Y far away from Earth? We want to read that label, and for that, we can just use a telescope that resolves that label. And it's not a philosophical issue. It's just getting the image. It's very simple.
Yeah.
That's all. So my point is, how do we get the image? We have to look. That's first thing. So people, a lot of people, including most of the scientific community, ridicules the subject, dismisses it, and says business as usual. My point is, nobody should argue that getting more evidence is not helpful, because the government says there are objects we don't understand. So all I'm saying is, let's get more data about these objects. Why would anyone object to that? And by the way, I'm not taking money from any other scientific projects. This money came from another direction, from the private sector. And so it will just, the aim of this project, the Galileo Project, would be to resolve this puzzle of what UAP are all about. What is the nature? And if we find that they are natural in origin, that they are some events in the atmosphere, or some objects that were produced by humans, or something else, so be it. We will understand something that was not understood before. and that advances our knowledge, instead of speculating about what they might be. I think it serves a very important purpose because the public wants to know what these objects are. And if we find that Oumumua is a hydrogen iceberg, a natural object, something that we've never seen before, made of pure hydrogen, which was a suggestion made in the literature, so be it. It would say that it's nothing like the rocks that we have found before in the solar system. So there must be nurseries making such objects at a very large abundance that we've never imagined. And so we learn something new about reality. So my point is, getting more data is a win-win proposition. You always benefit from getting evidence about what you're talking about. And I just cannot understand why would anyone make negative comments about a project whose goal is to get more data.
Yeah, makes a lot of sense.
Last time you were on, after actually off the air, I said you should write a treatise on critique on modern science, because you said that might not be a bad idea. And I think that when you look at what's going on, you mentioned all these people that are resistant to this idea. Well, it doesn't make sense because, like you mentioned before, science should serve the public, and nobody's even really doing this. You're like the first person or the first, scientist that we know of. Who knows what goes on behind closed doors in the government stuff? They might have their own people. I don't know. But in terms of like the public and everything, I think you're the first person to really take a look at this stuff and put a lot of money towards this idea of searching to figure out what these things are. Are they atmospheric? Are they natural? Are they possibly something, like you said, something from somewhere else, or some sort of von Neumann probe, some non-manned or some sort of AI technology from somewhere else? That's
exactly. No, so I want to emphasize that. Well, first of all, we don't want to make the mistake that the philosophers made during the days of Galileo. That's why we called it the Galileo Project. But the second point is to recognize that, artificial intelligence systems, we already have systems driving cars, and within 10 years, these systems will decide about medical procedures for people. They will replace doctors. They will do a lot of things. So you can imagine another civilization more advanced than ours that sent AI systems into space. And those AI systems are just like kids. You can basically educate them at a young age so that they learn from what you tell them. You give them the guidelines, the blueprint of how to interact with the world and what their goals should be. And then you send them out and they become autonomous. They operate on their own. They don't need to ask you again, especially because the distances between stars are so great that there is no time for them to hear guidance from whoever sent them. And just like kids, you send them to the world and then they are smart enough to learn and to operate by themselves. And I think that makes a lot of sense. And then an AI system that is equipped with a 3D printer could potentially replicate itself. And it could survive the long journey through interstellar space. So if you imagine a technological civilization that predated us, let's say by 1 billion years, and most stars formed billions of years before the sun. So just imagine one such civilization within 1 billion years. That's plenty of time to basically populate the entire galaxy with probes that replicated themselves.
Yeah.
There is plenty of time to do that. So is that the reality we live in? We don't know, but we need to look out in order to find out. It's not a matter of us deciding that there is nothing out there. We need to find out, learn from looking, whether we are alone, whether there is a smarter kid on the block.
Yeah, I like your approach too. You're not saying this or that. You're just saying let's look, and everybody's kind of giving you resistance, which doesn't make any sense. But I guess that's the world we live in.
Well, it's my approach. I maintain my childhood curiosity, so I behave like a kid. If you, in a way, adults tell kids this is the truth. Okay. And the kid says, I don't believe you. I want to figure it out myself,
Yeah.
And so the kid often gets bruised and runs into obstacles. But in that process, the kid learns something new about reality that the adult may not know, actually. And I think science is this privilege of behaving like kids because, you don't need to pretend. When you do science, you don't need to pretend that you know the answer in advance. Unfortunately, a lot of people want to boost their image and they pretend they know more. But science is a learning experience. You're trying to interact by experiments with reality, learn something new. And especially when something looks unusual, like UAP or like Oumumua not looking like a comet or an asteroid, that should be exciting. That's an opportunity to learn something new. But instead, my colleagues say, oh, it looks anomalous, but it's still a rock. It's natural, business as usual. Forget about it. Don't even talk about anything exotic. We need extraordinary evidence before we even consider other possibilities. And I say, if that's what you're saying, you will never collect evidence, because you say it's always whatever I thought before. It's a self-fulfilling prophecy. If you don't search for unusual things, you will never discover them.
So you mentioned earlier the UAP report. We did a whole episode on it, went through it kind of page by page. It's only 9 pages. They supposedly have a classified versions too that has more information and data in there. Is that something that the public or public scientists ever are privy to, or is that something that's all internal?
Well, you see, this question was posed to me as to whether I might want to have a look at the classified information, and my response is I prefer not to know, because it will tie my hands in a way. The government then would worry that even if I assemble open data later on, I could be biased subconsciously by what I know. So I prefer not to know and just collect new data. You see, because the old data may not be of the quality I want.
Sure.
Why worry about it? You can just, science is about reproducibility of results. The government says there are objects we don't understand. I say as a scientist, okay, let's figure them out. And that's what we plan to do in the Galileo Project. Basically, buy off-the-shelf instruments and look at the sky and see if there is anything unusual and figure it out ourselves, from our own data. I think that's a better approach than worrying or obsessing with past data, most of it, which is classified. Now, the one thing that intrigues me is that people that had access to this classified information, like former CIA directors, Brennan and Woolsey, and the former President Barack Obama, and many other people that had high-level positions, they all talk about it seriously. They say it's a serious matter, the objects look real, and it's really puzzling. And to me, that indicates that you can't just dismiss it. You can't just debunk it, as some people do, saying, oh, I can figure it out myself. Because the point is that the evidence we have that is publicly released is just the tip of the iceberg. So all these debunkers, basically what they're trying to say is that these serious people that we trust otherwise, that saw the classified information, do not know what they're talking about. When you are debunking the tip of the iceberg and you are claiming the iceberg doesn't exist, that doesn't make a lot of sense.
Right.
You should be modest enough. You should be humble and say, okay, this is the tip of the iceberg. Doesn't look convincing to me. But there are some people that saw a bigger chunk of the iceberg, and they tell me that the iceberg exists. So how, I shouldn't dare to dismiss the existence of the iceberg just based on the tip that I see. Of course, the tip may not be impressive.
Right. Well, you make a good point here too, because let's say they knew something or they know something more than what they're saying, and it's actually pretty good evidence. You would still need science to come in and confirm that, or present it in a way to present to the public, because let's face it, there's going to be a lot of people out there that still will deny it. And it would be a huge paradigm shift. And I think there would be a lot of people that wouldn't know what to do with that information.
Yeah, the fundamental question with respect to UAP is, are they human-made or natural versus are they extraterrestrial? Okay, so that's the fundamental. Now, if they're human-made, then they represent a major failure of the intelligence agencies, because it means that another nation produced technologies that we haven't anticipated, we haven't understood. And so that's a major national security concern, okay? And I'm pretty confident that the government thought about it. And the fact that it goes to Congress and says, we can't figure it out, means, as far as I'm concerned, that it's probably not, if these objects are indeed real, they probably cannot be the result of some equipment produced by other humans. Now, it's possible that there are some atmospheric phenomena that we've never understood, okay? And for that, we need better data. And that's what the Galileo Project aims to do. And you do it by elimination, right? So just like a detective, like Sherlock Holmes, he would put all of the possible explanations on the table and then rule them out one by one. And whatever remains, however unlikely, must be the truth. So if you rule out human-made, suppose we get future data with the Galileo telescopes, okay? And we can rule out that it's human-made because we don't have technologies to produce such object.
Right.
And then we rule out the possibility that it's atmospheric based on observations with telescopes in the optical band, and then infrared observations, and then radio or radar observations, and all kinds of additional data implies that it cannot be atmospheric, that it's something, these are real objects. So we rule out those possibilities. At that point, it becomes real, that they might be of some other origin, and we have to try and figure it out.
How much coverage will all these sensors and telescopes have? Like, where will you be searching for them? Are you going to look in the areas where there was all these sightings off the coast of California and off the East Coast? I mean, obviously out west, it seems like there's a lot more sightings near the desert and the coast than I guess Chicago's got a decent amount, and the East Coast has some too. But where will you be looking for these?
Well, that's an excellent question. And the fundamental question here is whether it's a selection effect, that these are the areas that were patrolled most often. And as a result, these are the areas also that have a lot of technological activity that is human-made, in them. And we don't know. And all we can do is distribute the telescopes in many different locations. And the more telescopes we have, the better is the information that we will get. And that's why I'm very, very hopeful. I very much hope that more funders will come along and increase the level of funding that we have from $2 million to maybe $10 or more million, because that would really allow us more than 100 telescopes that we can put in many locations. So the more telescopes we have, the better we can address your question, because we can place them in different places. We can collect much more data. It will be videoing the sky, or basically take video images of the sky, but we want to cover as much sky as possible.
Can anybody donate? Do you have like a donate button on your page or anything like that?
Okay, so we're in the process of establishing a mechanism for crowdfunding, which is a little more challenging.
Right.
But anyone with interest to donate more than $50,000 should approach me directly, and through my contact email, aloeb@cfa.harvard.edu, and then I can guide that person as to how to proceed. So large donations, we have a special path to follow. With crowdfunding, we haven't yet established, but we hope to do so.
Yeah, because I think there would probably be a lot of people that are interested in this that donate to other things, even things that aren't as productive or efficient, I guess. Like people are donating to things now that aren't really giving them any answers. So I think that something like this would probably be more beneficial if you actually are looking for answers.
We would be grateful to anyone.
Yeah. Is there anything, did you read the 9-page report, the UAP report, and was there anything in there other than just these anomalies that they can't explain that piqued your interest? Was there something in there that you saw that maybe led you to believe that this is a more worthy cause than you thought about before?
Yeah, the most important statement that I found in the report was the admission that some of the objects must be real. And that's based on the fact that they were detected by multiple sensors, multiple instruments. Some of them were detected by infrared sensors and optical cameras, and also radar systems, and multiple people seeing the same thing, doing the same thing. So altogether, this statement is extremely significant, because if you listen to the debunkers, which dominate the media, by the way,
right?
They often say, oh, maybe it's a smudge on the camera, maybe it's a malfunction of the instrument, maybe it's some other thing that was misunderstood. And the report says that they believe that some of these objects are real. Now, of course, it's a mixed bag. And of course, most of the reports from the past of unidentified phenomena may be explained by mundane explanations. But my point is, we just need one object. That's all.
Right.
One object of extraterrestrial origin for this to have a major impact on society. And even if most of the objects have mundane explanations, that doesn't say anything, because we need to clear up all of them. Okay? And what the Galileo Project will do is collect evidence without any preference for the type of object, basically collecting blindly data from the sky, so that it's just like a fishing expedition where you throw the hook and you are not anticipating any particular type of fish. And the data would be of high enough quality for us to catch any fish that shows up.
Yeah, that's interesting. When I think about this stuff too, obviously, the normal public, we like to speculate and, give our own take on what's going on. But you make a good point too. Like, let's not jump to conclusions. Obviously, like you said, science is all about data and observation, and you're not going to jump to any conclusions. And I think that that's kind of the bird's eye view that we need on this topic. What about like other things though too? Like our government has satellites, and these satellites can zoom in crazy amounts. And is that something to think about in the future too, is potentially looking at these things? Because I mean, who knows what they have and how clear their pictures are. But if we did have a satellite looking for these things, I would imagine that it's probably pretty efficient, right?
Yeah, that's what I would think. But satellites are much more expensive.
Right.
So if I had the 100 times more money.
Somebody listen out there. If you're a billionaire, let's get this going.
Yeah, this is what we need.
Elon, if you're out there. I know you don't believe in aliens, but let's get you in that realm.
We know he's tuned into Mike and Maurice too right now. It's not working. He's listening.
Yeah, I mean, if we equip any of the existing satellites or future satellites with appropriate cameras, and we could get quite useful data. And of course, there are U.S. government-owned satellites looking down, but as I said, the data is classified, and I prefer not to get engaged, not to look at that data, because it would limit what I can say, it would limit what I can explore with open data. And so the private sector can help us a lot. And if there is any wealthy individual that is interested, I think that would be a fantastic opportunity. I mean, looking down, you can cover a large chunk of the Earth much more effectively than with telescopes on the ground.
Absolutely. Another main part of your team, I believe I saw in the video, is it Frank Lycan? Is that how you pronounce his name?
Lycan. Yes.
Lycan. So, and he's an astrobiologist, correct? What's he going to be doing for the project? Like, what's he going to be contributing?
Yeah, even though he is interested mostly in astrobiology, he's particularly excited about this project, the Galileo Project. In fact, he co-founded it with me after reading my book. So he came to the porch of my home to ask some questions about my book, and was very excited by the vision that I described about a scientific exploration of the nature of objects near Earth. And we established this project together. And he's also planning to contribute to this project. He's the CEO of Bruker Corporation, which is a major corporation for producing instruments, scientific instruments.
Okay.
So he is very engaged in the research team right now. He's a member of the research team, and we have many other members that you can find on the website. And yeah, he's just a member of the team like everyone else, even though, he is a very accomplished businessman.
Yeah, that's interesting. And actually, it might come in handy if you were to find something, right, biological at some point or something related, but to bio.
I think it's very unlikely that if we find anything from an extraterrestrial origin, that it has biology in it or some creatures, because such things will not survive long journeys. If you want to send...
What about tardigrades, though? Because I know that they're not intelligent, but they can survive, right? The vacuum of space.
Not much longer than 1 million years. You see, what you need across, if you want very long, 1 million years would allow you to move with chemical rockets across a distance of 100 light years, which is roughly 1% of the size of the Milky Way galaxy. So you need something to survive 100 million years. And as far as we know, life is not likely to survive 100 million years under the harsh conditions of space. That's really difficult. So it makes much more sense to send equipment. And by the way, artificial intelligence could be far better than natural intelligence. We already know that.
Right.
Self-driving cars could be much more reliable than taxi drivers.
Yeah, like we discussed earlier, the von Neumann probe idea and artificial intelligence kind of, that's where we're headed, right? So,
Exactly.
Something was so much more advanced and it's similar. I guess we would have to wait and see. But yeah, we can...
By the way, it will be, if we find something, it will be a view at our own future, so to speak, because they predated us. They created something that, if we were to be left alone, we would create in our future. So by finding equipment from more advanced technological civilization, you can get a peek at our own future. And entrepreneurs in Silicon Valley should be very excited about it because it's a chance for them to leap into our future and make a lot of money out of it.
Yeah, and we know they like that, so that should be a great incentive for them. Look, I'm really excited for this, and we really appreciate your time and coming on here and sharing all your information. And it's really inspiring to see somebody that is at the level that you're at and still interested in these topics. And I think we need more of that. But if we don't, we still have you, right? So just keep doing what you're doing, and we'll keep chipping away ourselves. And we're interested in.
I'm happy to say that, even though I advocated for that over the past 6 months on my own, now I have a team of 50 people, right?
Yeah.
So if it keeps growing like that, eventually it will become mainstream within the coming years. So just wait and see.
Well, if you need a photographer, you can strap me to a rocket.
Yeah, Maurice is a professional photographer, so I know he appreciates some of this stuff. But yeah, again... Yeah. Thank you so much for coming on. I'll put the link down below. Check out Avi's book, Extraterrestrial. It came out earlier this year, so go please check that out. It's a great book. And thank you so much for coming on, and I have no doubt we'll probably have you on again in the future. So,
thank you for hosting me.
Yeah, no problem. Everybody stay safe out there. We love you. Again, if you're interested, you can head on over to our Patreon at patreon.com/MindEscapePodcast. For just $2 a month, you'll get exclusive guest episodes and segments. We did one with Avi last time he was on, so go check that out. And again, thank you so much, and we'll catch you next time. And everybody stay safe out there. We love you. Peace.